Norway is no stranger to impressive feats of engineering, but the country's latest project is taking things to a whole new level. The $47 billion underwater floating highway known as the Coastal Highway Route E39 is set to be the longest and most complex transportation infrastructure endeavor in the nation's history. This mind-boggling project will feature submerged floating tunnels, bridges, and traditional tunnels, all designed to navigate the challenging terrain of Norway's fjords and mountainous regions. The vision. Norway's vision for the E39 coastal highway is a bold one, aiming to transform transportation along the country's western coast. At its core, the project seeks to drastically improve connectivity and reduce travel times between key cities and towns. By eliminating the need for 7 ferry crossings, each taking around 45 minutes and costing about $16 per trip, the new highway will cut the journey from Kristiansand to Trondheim from 21 hours to just 10. This seamless, uninterrupted route will make travel more efficient and predictable for residents, businesses, and tourists alike. But the ambitions of the E39 project extend far beyond mere convenience. The highway is seen as a vital tool for urban stabilization and revitalization in rural and remote areas along the coast. Many of these regions, such as Tysnes, have seen significant population declines over the past century due to their inaccessibility. By providing easier access to essential services like healthcare, education, and employment opportunities, the E39 has the potential to make these areas more livable and attractive, potentially reversing long-standing demographic trends. The economic benefits of the project are also substantial, with 60% of Norway's exported goods produced along the west coast, where a third of the population resides. Improving transportation infrastructure is crucial for boosting efficiency and reducing costs. The E39 will streamline logistics for goods, making it easier and faster to move products from factories to ports and beyond. This in turn is expected to stimulate economic growth and create new opportunities for businesses and communities along the route. Moreover, the E39 coastal highway is designed to showcase Norway's commitment to environmental sustainability and preservation. Traditional road infrastructure, such as bridges and standard tunnels, can have significant ecological drawbacks. The innovative solutions being employed in this project, including submerged floating tube bridges, SFTBs, aim to minimize the highway's impact on the pristine natural beauty of Norway's fjords and coastline. These state-of-the-art engineering techniques not only reduce environmental disruption, but also provide greater resilience against the harsh weather conditions that often lead to road closures and ferry cancellations in the region. As the E39 project pushes the boundaries of what's possible in transportation infrastructure, it has the potential to set a new global standard. Groundbreaking engineering. The Coastal Highway project is a testament to the ingenuity and innovation of modern engineering. To navigate the rugged terrain and deep fjords along Norway's western coast, the project employs a combination of conventional tunnels, bridges, and groundbreaking submerged floating tunnels, SFTBs. These engineering marvels are designed to withstand the harsh conditions of the Norwegian Sea while minimizing environmental impact and ensuring the safety of travelers. One of the most challenging aspects of the project is the crossing of the Sognefjord, Norway's longest and deepest fjord. Engineers are considering several solutions, including a floating submerged tunnel supported by pontoons, the world's largest suspension bridge with towers reaching 435 meters, and a hybrid design that combines floating pontoon bridges with submerged tunnels. Each option presents its own set of challenges, from the immense pressures exerted on the structures to the potential impact on the fjord's ecosystem. The submerged floating tube bridges are a particularly innovative solution. These structures consist of concrete tubes suspended about 100 feet below the water surface, anchored to the seabed or pontoons at roughly 800-foot intervals. This design allows ships and submarines to pass safely above the tunnels while providing a stable, weatherproof passage for vehicles. The tubes are engineered to withstand the immense pressures of the deep water and the constant motion of the waves, ensuring a safe and reliable crossing for travelers. Another marvel of the E39 project is the Rogfast Tunnel, which will be the longest and deepest subsea road tunnel in the world upon completion, stretching 27 kilometers and reaching depths of up to 390 meters below sea level. The Rogfast Tunnel is a feat of engineering that pushes the boundaries of what is possible in tunnel construction. The tunnel will feature emergency exits every 250 meters, along with emergency lights and phones at regular intervals, to ensure the safety of motorists in case of an emergency. The construction of these engineering marvels requires cutting-edge techniques and materials. From the reinforced concrete used in the submerged floating tunnels to the advanced drilling and excavation methods employed in the Rogfast tunnel, every aspect of the project demands precision and innovation. Engineers must also contend with the challenges posed by the harsh Norwegian climate, including strong winds, heavy rainfall, and the potential for seismic activity. Despite the immense challenges, the engineers behind the E39 Coastal Highway project remain undaunted. They are driven by a vision of a more connected, sustainable, and prosperous future for Norway's western coast. By pushing the limits of what is possible in transportation infrastructure, they are not only transforming the way people travel within the country, but also setting a new global standard for innovative, environmentally conscious design. However, bringing this ambitious vision to life is no easy feat. Engineering challenges. In addressing these engineering challenges, the team behind the E39 Coastal Highway project has had to devise groundbreaking solutions that push the boundaries of what's possible in modern construction. One of the most significant hurdles is navigating the deep, wide fjords that punctuate Norway's western coast. The Sognefjord crossing, for example, spans a staggering 3,700 meters and plunges to depths of 1,300 meters. To traverse this formidable obstacle, engineers are considering a range of innovative options, from submerged floating tunnels suspended by pontoons to a record-breaking suspension bridge with towers soaring 435 meters into the sky. The Submerged Floating Tube Bridge, SFTB concept, is a particularly inventive approach to fjord crossings. While the idea itself dates back to the late 19th century, only recent advancements in materials, science, and engineering have made it a viable solution. The proposed design involves anchoring concrete tubes to the seabed or floating pontoons at regular intervals, allowing them to sit about 100 feet below the water's surface. This positioning ensures that ships and submarines can pass safely overhead while providing a stable, weatherproof route for vehicles. However, the immense pressures exerted on the structure at such depths present a significant challenge, requiring engineers to carefully calculate and reinforce the tubes to withstand the constant stress. Another major engineering feat is the Rogfast tunnel, set to become the world's longest and deepest subsea road tunnel. Boring through 27 kilometers of rock and reaching depths of up to 390 meters below sea level, this tunnel pushes the limits of conventional drilling and excavation techniques. Engineers must contend not only with the sheer scale of the project, but also with the geologic complexities of the Norwegian seabed, which can include unstable rock formations and seismic activity.
To ensure the safety of motorists, the tunnel will feature emergency exits, lights, and phones at regular intervals, adding another layer of complexity to the design and construction process. Beyond the fjords and tunnels, the rugged terrain of Norway's western coast presents its own set of challenges. The E39 Coastal Highway must navigate steep cliffs, rocky outcroppings, and areas prone to landslides and avalanches. To mitigate these risks, engineers are employing advanced geotechnical analysis and monitoring systems,
allowing them to identify potential hazards and adapt the design accordingly. In some cases, this may involve reinforcing hillsides, constructing protective barriers, or even rerouting the highway to avoid particularly treacherous areas. Throughout the project, engineers must also consider the environmental impact of their work. The Norwegian Public Roads Administration has been studying the country's natural landscape for years to determine how to construct the E39 with minimal disruption to local ecosystems. This involves careful route planning to avoid sensitive habitats, as well as the use of sustainable materials and construction methods wherever possible. As engineers continue to grapple with these myriad challenges, they are also exploring cutting-edge materials and technologies that could revolutionize the way we build transportation infrastructure. Materials and construction, the style of constructing the E39 Coastal Highway are impressive as the engineering feats themselves. Transporting and compiling the materials needed for these groundbreaking structures presents a unique set of challenges, especially in the harsh marine environments of Norway's western coast. From the reinforced concrete tubes used in the submerged floating tunnels to the steel cables and floating pontoons that keep them stable, every component must be carefully manufactured, shipped, and put into place with precision. One of the most critical materials in the construction of the floating tunnels is advanced polymers. These high-strength, lightweight materials are essential for creating the buoyant segments that will support the concrete tubes beneath the water's surface. The polymers must be able to withstand the constant pressure of the deep sea while also resisting corrosion and degradation over time. To ensure the highest quality, these components are typically manufactured on land and then transported to the construction site by specialized vessels. Steel also plays a vital role in the construction of the E39 coastal highway. From the cables that anchor the floating pontoons to the reinforcing bars that strengthen the concrete tubes, steel is used throughout the project for its durability and tensile strength. However, working with steel in marine environments presents its own set of challenges. The material must be treated to resist corrosion from salt water and protected from the constant motion of the waves and currents. Transporting these massive steel components to the construction site is no small feat. The cables and reinforcing bars are typically manufactured on land and then loaded onto specialized barges or ships for transport to the fjords. Once there, they must be carefully maneuvered into place using cranes and other heavy machinery designed to operate in marine environments. The floating pontoons that support the submerged tunnels are another critical component of the E39 coastal highway.
These massive structures, which can measure up to 800 feet in length, are typically made from reinforced concrete and are designed to provide a stable platform for the tunnel segments. Like the other components, the pontoons are manufactured on land and then towed to the construction site by powerful tugboats. Once all the components are in place, the real work of assembling the floating tunnels begins. This is a delicate and time-consuming process that requires specialized equipment and highly skilled workers. The concrete tubes must be carefully lowered into place and connected to the floating pontoons using steel cables and other anchoring systems. The tubes themselves must be sealed and pressurized to create a stable, waterproof environment for vehicles to pass through. Throughout the construction process, engineers must also contend with the challenges posed by Norway's harsh coastal weather. High winds, heavy rainfall, and strong currents can all impact the safety and efficiency of the work, requiring careful planning and constant monitoring to ensure that the project stays on track. Despite the immense challenges involved, the construction of the E39 coastal highway is a testament to the ingenuity and perseverance of the engineers and workers involved. By combining cutting-edge materials and innovative construction techniques, they are bringing to life a vision of a more connected, sustainable future for Norway's western coast. However, with such ambitious engineering comes the need for equally rigorous safety measures. From emergency exit strategies to fire suppression systems, the E39 coastal highway must be designed with the utmost attention to detail to ensure the well-being of the travelers who will traverse its tunnels and bridges.
Safety measures. Securely at the forefront of the E39 coastal highway project, engineers have implemented a comprehensive array of measures to ensure the secure passage of motorists through the tunnels and across the bridges. The Rogfast Tunnel, a critical component of the new coastal highway, exemplifies this commitment to safety, featuring emergency exits at 250-meter intervals throughout its length. These strategically placed exits provide a vital lifeline for travelers in the event of an unforeseen crisis, allowing them to quickly and safely evacuate the tunnel if necessary. In addition to the emergency exits, the Rogfast Tunnel is equipped with a network of emergency lights and phones positioned at regular intervals along the route. These essential communication and illumination systems ensure that motorists can maintain contact with emergency services and navigate their way to safety, even in the face of a power outage or other technical failure. Fire and explosion safety are also paramount concerns in the design of the E39 coastal highway. To mitigate these risks, Norwegian engineers have conducted extensive small-scale fire and explosion tests within the tunnels. These controlled experiments simulate worst-case scenarios, such as a collision between large vehicles or a truck carrying hazardous materials, enabling engineers to develop robust safety protocols and design features that can withstand even the most extreme conditions. The submerged floating tube bridges, SFTBs, present their own unique set of safety challenges, which engineers have addressed through meticulous design and planning. By positioning the SFTBs at depths between 20 and 50 meters below the water's surface, engineers have ensured that the structures are protected from potential collisions with surface water traffic, while also maintaining manageable water pressure levels. The floating tunnels are further stabilized by a system of cables anchored to the seabed or pontoons floating at regular intervals along the surface. The pontoon system in particular offers an added layer of safety by making the tunnel's location visible to boats and ships above. Despite these precautions, engineers have also developed an extensive emergency response strategy specifically tailored to the unique challenges of the SFTBs. This comprehensive plan includes standardized exit procedures for motorists, as well as a dedicated response team that can swiftly access the tunnels in the event of an emergency. Much like conventional tunnels, the submerged portions of the E39 coastal highway feature escape routes that allow travelers to safely return to the surface should the need arise. The mid-route intersection of the Rogfast Tunnel, which connects to the island of Kvitsøy, serves as a microcosm of the project's overarching commitment to safety. This critical juncture incorporates the same rigorous safety measures found throughout the tunnel, including emergency exits, lighting, and communication systems, ensuring that motorists can navigate this complex intersection with confidence. As the E39 Coastal Highway project continues to push the boundaries of engineering and design, the unwavering focus on safety remains a guiding principle. By incorporating cutting-edge technology, rigorous testing, and comprehensive emergency response strategies, engineers are creating a transportation network that not only showcases the marvels of modern engineering, but also prioritizes the well-being of the travelers who will ultimately benefit from this groundbreaking infrastructure. Economic and environmental impact. This project's influence extends far beyond the realm of transportation, promising to reshape Norway's economic and environmental landscape in significant ways. As the country embarks on this ambitious endeavor, experts are carefully analyzing the potential benefits and challenges that lie ahead. From an economic perspective, the project is expected to yield substantial dividends. By improving connectivity between remote coastal regions and major urban centers, the E39 Coastal Highway will open up new opportunities for economic growth and development. Tourism, in particular, is projected to experience a significant boost. With more accessible and efficient travel routes, visitors will be able to explore Norway's stunning coastal landscapes with greater ease, potentially increasing the country's annual tourism revenue, which currently stands at over 50 billion krona, $5.6 billion USD. Beyond tourism, the highway is also anticipated to stimulate economic activities in previously isolated areas. Improved links between islands and the mainland will foster the growth of businesses, creating jobs and revitalizing local economies. Regions like Tysnes, which have witnessed population declines due to limited accessibility, may see a reversal in this trend as enhanced connectivity attracts new residents and enterprises. However, as with any large-scale infrastructure project, environmental considerations remain a key concern. The engineers behind the E39 Coastal Highway are acutely aware of the need to minimize ecological disruption while maintaining the natural beauty that makes Norway's coastal regions so iconic. To address this challenge, innovative solutions like submerged floating tube bridges, SFTBs, have been proposed as an alternative to traditional bridges. By positioning these structures beneath the water's surface, engineers aim to preserve the visual aesthetics of the landscape, reducing the highway's impact on the pristine fjords and islands. Professor Niels Erik Anders Ronquist, a key figure involved in the project, encapsulates this commitment to environmental stewardship, stating, "The best and most efficient highway is the one that's almost completely hidden." This philosophy underscores the importance of striking a delicate balance between infrastructure development and ecological preservation.
To ensure that this balance is maintained, the Norwegian Public Roads Administration is conducting extensive studies of the natural landscape. By gaining a deep understanding of the ecosystems along the proposed route, engineers can develop strategies to minimize lasting ecological damage during the construction and operation of the highway. This meticulous approach to environmental planning is a hallmark of the E39 Coastal Highway project, setting a new standard for sustainable infrastructure development. As Norway navigates the complex interplay between economic growth and environmental responsibility, the E39 Coastal Highway project serves as a powerful testament to the country's commitment to building a more connected, prosperous, and sustainable future. The lessons learned from this groundbreaking endeavor are poised to resonate far beyond Norway's borders, inspiring a new era of innovative, eco-conscious infrastructure projects around the globe. With the world watching, Norway's ambitious undertaking has the potential to serve as a model for similar initiatives in other countries facing comparable challenges. Global implications. As the world takes notice of Norway's pioneering E39 Coastal Highway project, the potential for this ambitious endeavor to serve as a global model for innovative infrastructure solutions becomes increasingly apparent. With countries like China and Italy already expressing interest in pursuing similar submerged floating tunnel projects, the stage is set for Norway's expertise and experience to guide the development of cutting-edge transportation networks worldwide. The E39 project's collaborative approach,
which brings together experts from various disciplines and institutions, offers a blueprint for tackling the complex challenges associated with large-scale infrastructure initiatives. By fostering partnerships between
Norwegian Public Roads Administration and researchers from esteemed universities, such as the Norwegian University of Science and Technology, the University of Stavanger, and Chalmers University of Technology, the project has created a framework for knowledge sharing and problem solving that transcends national boundaries. These international collaborations have been instrumental in addressing the myriad technical challenges posed by the E39 Coastal Highway project.
With approximately 50 PhD candidates from 3 major Nordic universities working to develop solutions for issues ranging from tunnel maintenance and safety to broader infrastructure concerns, the project has become a hub for innovation and expertise that can be leveraged by other nations embarking on similar endeavors. As countries like China and Italy look to Norway's example, the successful completion of key components of the E39 project, such as the Rogfast Tunnel and the Sognefjord Crossing, will serve as powerful demonstrations of the feasibility and potential of submerged floating tunnels and other pioneering design solutions. By setting new engineering benchmarks, these milestones will bolster confidence in the viability of such projects and inspire other nations to adopt similar approaches to their own infrastructure challenges. The Rogfast Tunnel in particular stands as a testament to the transformative potential of the E39 Coastal Highway project. As the world's longest and deepest undersea road tunnel, this 27-kilometer marvel will not only revolutionize travel within Norway, but also serve as a proof of concept for the safety and efficacy of submerged floating tunnels on a global scale. Similarly, the Sognefjord crossing proposal, with its innovative combination of traditional suspension bridges, submerged floating tunnels, and hybrid floating pontoon bridges, showcases the versatility and adaptability of the solutions being developed within the E39 project. As other countries grapple with the unique challenges posed by their own landscapes and transportation needs, the Sognefjord crossing will serve as a valuable case study in the application of diverse, cutting-edge design strategies. As Norway continues to blaze a trail in the realm of innovative infrastructure development, the ripple effects of the E39 Coastal Highway project are poised to be felt far beyond the country's borders. By setting a new standard for collaboration, innovation, and engineering excellence, Norway is not only reshaping its own transportation landscape, but also providing a roadmap for other nations to follow as they seek to build a more connected, sustainable, and prosperous future. Timeline and key milestones. As anticipation builds for the completion of key milestones, the E39 Coastal Highway project's timeline stretches out to the year 2050, a testament to the sheer scale and complexity of this groundbreaking endeavor. The journey from initial planning stages to the projected completion date is marked by a series of transformative developments, each one bringing Norway closer to realizing its vision of a more connected and prosperous future. The Rogfast Tunnel, a centerpiece of the E39 project, is slated for completion in 2029, having begun construction in 2018. This 27-kilometer subsea marvel will not only revolutionize travel between Kristiansand and Trondheim, but also serve as a powerful demonstration of the feasibility and potential of submerged floating tunnels on a global scale. With depths reaching up to 390 meters below sea level, the Rogfast Tunnel will set new engineering benchmarks and bolster confidence in the viability of similar projects worldwide.
As work on the Rogfast Tunnel progresses, planning and potential construction of other innovative structures, such as the Sulafjorden Bridge, the Sognefjord Crossing, and the Bømlafjord Floating Bridge, continue in parallel. These structures showcase the versatility and adaptability of the solutions being developed within the E39 project, with each one presenting its own unique set of engineering challenges and opportunities. The Sognefjord Crossing, in particular, stands as a testament to the project's commitment to pushing the boundaries of what is possible. With its innovative combination of traditional suspension bridges, floating bridges, submerged floating tunnels, and hybrid floating pontoon bridges, this crossing will serve as a valuable case study in the application of diverse, cutting-edge design strategies. As the E39 Coastal Highway project moves forward, each milestone achieved brings Norway one step closer to its goal of eliminating ferry crossings and improving connectivity between its coastal regions. The successful completion of the Rogfast Tunnel in 2029 will mark a significant turning point, demonstrating the viability of the project's ambitious vision and setting the stage for the realization of subsequent milestones. Beyond the Rogfast Tunnel, the timeline for the E39 project is punctuated by a series of key developments, each one contributing to the gradual transformation of Norway's coastal transportation network. From the construction of the Sulafjorden Bridge to the completion of the Sonafjord crossing, these milestones will stand as testament to the ingenuity, perseverance, and collaborative spirit that have driven the project forward.
Community and cultural reactions. As progress continues on the E39 Coastal Highway project, it has elicited a spectrum of reactions from the communities it will impact most directly. While many residents express enthusiasm for the potential economic benefits and improved accessibility the project promises, others voice concerns about its cost, environmental impact, and safety implications. Supporters of the project, particularly in regions like Tysnes that have experienced significant population decline due to their previously inaccessible nature, see the underwater floating highway as a lifeline. Mayor Martin Kleppe of Tysnes emphasizes the inadequacy of the current ferry system, which, despite offering scenic views, presents more challenges than conveniences. He asserts that the new highway is crucial for revitalizing rural municipalities and reversing the trend of population loss. However, apprehension about the project's budget, which could exceed the estimated $47 billion, and its potential environmental consequences in Norway's pristine natural landscapes has sparked a wave of concern among some community members. To address these issues, the Norwegian Public Roads Administration has been actively collaborating with universities, researchers, and engineers to develop solutions that minimize the project's ecological footprint and maximize safety. This collaborative approach has been instrumental in integrating community feedback into the design and execution phases of the E39 project. By working closely with local stakeholders, the project aims to create a transportation network that not only meets the practical needs of the population, but also enhances their quality of life by improving access to essential services like healthcare, employment opportunities, and education. The promise of economic revitalization in remote areas has been a key factor in garnering local support for the project. With improved accessibility expected to attract new residents and businesses, many communities along the route are hopeful that the underwater floating highway will help to reverse the trend of population decline and breathe new life into their regions. As construction progresses and the project's vision begins to take shape, the Norwegian Public Roads Administration remains committed to maintaining open lines of communication with the communities along the E39 route. By actively seeking input and addressing concerns throughout the development process, the project aims to create a transportation solution that is not only technologically innovative, but also socially and environmentally responsible. The successful integration of community feedback into the E39 Coastal Highway project serves as a model for future infrastructure initiatives, highlighting the importance of collaboration and public engagement in the planning and execution of large-scale projects. Maintenance and long-term sustainability. As the project progresses towards its ambitious goals, ensuring the long-term sustainability of this monumental structure becomes a top priority. The Norwegian Public Roads Administration, NPRA, has developed a comprehensive maintenance strategy that includes regular inspections, advanced monitoring systems, and the implementation of intelligent transport systems. These measures are designed to identify potential structural issues early on and facilitate preventive maintenance, thereby minimizing the need for costly repairs and prolonging the lifespan of the highway. To tackle the unique engineering challenges posed by the project, Norway has fostered collaborations with local universities and international experts. The Norwegian University of Science and Technology, the University of Stavanger, and Chalmers University of Technology are among the institutions working closely with the NPRA to develop innovative maintenance solutions. By leveraging the collective knowledge and expertise of these partners, the project aims to create a robust and resilient infrastructure that can withstand the test of time. One critical aspect of the maintenance strategy involves preparing for potential emergencies such as fires or explosions caused by collisions between large vehicles or trucks carrying hazardous materials. To this end, the NPRA plans to conduct small-scale fire and explosion tests within the tunnels, allowing response teams to develop standardized exit strategies and ensure quick access to the affected areas. The Rogfast Tunnel, a key component of the coastal highway, will feature emergency exits every 250 meters, along with emergency lights and phones at regular intervals, further enhancing the safety and security of travelers. In addition to emergency preparedness, the project also places a strong emphasis on environmental sustainability. The development of intelligent transport systems, such as the use of solar energy to create ice-free road surfaces during the winter months, demonstrates the NPRA's commitment to reducing the highway's ecological footprint while simultaneously improving road safety. This innovative approach to maintenance not only minimizes the structure's impact on Norway's pristine natural landscapes, but also sets a new standard for environmentally conscious infrastructure projects worldwide. The NPRA's extensive research into Norway's natural landscape has been instrumental in shaping the project's maintenance strategy. By studying how automobiles and the environment can safely coexist, the administration has gained valuable insights into the best practices for maintaining the tunnels and ensuring their long-term sustainability. This knowledge will be continuously refined and applied throughout the lifespan of the coastal highway, enabling the structure to adapt to changing environmental conditions and evolving transportation needs. As the E39 Coastal Highway project moves forward, the successful implementation of its maintenance strategy will serve as a testament to the power of collaboration, innovation, and environmental stewardship. By bringing together local and international expertise, embracing cutting-edge technologies, and prioritizing sustainability, Norway is setting a new benchmark for the development and maintenance of large-scale infrastructure projects.